Hi, this is Prof. Redder. This is the video I promised you in class on September the 1st regarding an application that I created for Iterator demo and the fact that I failed to get it uploaded properly on Dropbox so I could use it in class. So let me go through essentially what I was going to go through in class today. You can see the application running right here. This is it. And as you notice right here, I've got some items in a list box, and that these items are strings. This one, first item, is the string, followed by an indication of the index number within the string, or within a list of strings that this thing resides. And so first item is in index 0, or the item with index 0. Second item is at index 1, and so forth. And if I wanted to iterate through them all, I could get something like this. And in fact, that's how I populated this list box, was by using an iterator that knows how to iterate through this particular aggregate of a list of strings by hitting every item in the list. The odd iterator iterates only through those with odd indices, and the even iterator only with even indices. And so I've got three different iterators going here, and the purpose of this app is to show you how to manage that, or a way to manage that at least. So what I want to do is I'm going to start out by looking at the aggregate class, and the aggregate class is really pretty simple, and there's a little error in it as well. And let's take a look at what the UML diagram for the iterator pattern says should be in here. I do have an aggregate class right here, and I've got a concrete aggregate class right here, and you can see that that's what is required, an aggregate class, and the concrete aggregate is derived from the aggregate class. And as you'll see, that's exactly what I've got. But I've got these collapsed because I don't want you to see my error right this moment. I'm going to show you in about 12 seconds. But you'll notice that the aggregate class needs to have a public method that is called create iterator, or something to indicate that that's what it does, and returns an iterator. And the concrete aggregate also needs a method like that. And so I really needed to declare that up here, and I didn't. And instead I just put it down here. And that's a violation of the aggregate class as indicated by the iterator pattern. And I should fix that, but I didn't. And I kind of didn't, I guess, because I wanted to show you how you can easily mess up, but I can easily fix that. I'm not going to right now. And I didn't do it on purpose to show you, but when I did it and realized it, I thought I'd leave it that way just so you could see a screw up here. Okay, so it's not fatal though in this particular case. So what I've got is a method here called create iterator as required. I have this iterator type that you can see right here, and the iterators that I allow within this aggregate are the total iterator, an even iterator, and an odd iterator. Notice that that's an enum. Those are names of my choosing, and I call this collection, this enum, iterator type. Another thing I want you to notice is that the abstract class for aggregate is derived from list of string. This is something that's defined in the .NET framework, the list class. It's a collection class, and then the data type of the things in the list can be specified in this way. And so that's pretty close, except I should have create iterator up here, as I said. And now we get down here to the actual aggregate that I've got, and here's my create iterator class, or method. In order to create an iterator for an aggregate, a concrete aggregate, I simply pass the type of iterator I want, and it creates this iterator, as you see, and it does it by calling a method called create total, or create even, or create odd iterator. Let's look at create odd iterator because it's just right here. And what I do is I pass this. Well, what is this? It's one of the things of this type. It's a concrete aggregate, something that I've created, and I'll show you where I created that. And it's derived from aggregate, which is of type aggregate, and that's why I can say aggregate there, is because this is one of these, which is one of these. And I could really say list of string here, but that violates the principle of the iterator pattern, because if you look at it, it says, maybe it doesn't say here, but it indicates that when we create an iterator for this, we need to provide it the aggregate. It needs to have access to the aggregate that we're going to do this with. So I'm just passing this along, and that's not necessarily required in this, but that's the way I chose to do it. All right, and you can see all three of these are essentially the same except for the name, and the name gets called based on the iterator type I've selected. Okay, so that's about all there is to say about the aggregate class. Let's actually go over here and look at how I went about loading this aggregate. This is, I've created a concrete aggregate object here and put it in a variable called aggregate, pointed to it from there. And if you look at this, there's how I created it. Really simple code. The aggregate class is a list of string. The list class has an add method. The add method adds the object in its argument. The argument is an object of type string, and so this adds this string to the aggregate, and it adds it in the first position, in other words, position 0. So here I've got this, here I've got what's going on, there I've got what's going on right here. Let's look at the iterator, and the iterator has an aggregate object in it so that we can tell which aggregate we're going to iterate through. It's required to have these three methods. Notice that this is the abstract class, and as a result, it's going to actually allocate space for this every time we create anything derived from iterator. An aggregate object will be created, and these methods will be expected. And I showed you how we can deal with that with regard to the .NET Framework and Visual Studio helping you to build essentially the template or build the skeleton of this class, the total iterator class. Notice that I've also got even iterator and odd iterator on down there, but here's the total iterator class. I've got a constructor that accepts an aggregate object, and I store that aggregate object in this thing right here, as you can see right there. First, next, is done, and current item are really quite simple. In this case, I want to iterate. This is the total iterator, you can see right there, and I want to iterate through all of the elements in the list. Not necessarily in the order they're there, but that's typically what you do. And so in this case, I'm going to start with the first one at index 0. So I just set first. When I use this value current index, I use it to say what's the current object that I've got. And so the current value that I've got when I set current index to 0 is the first one. If I want the next one beyond the one I'm looking at, I look at current index plus plus. That's the index of the next one, usually. If current index is bigger than count, aggregate count, aggregate, remember, is a list of strings. Count is a member property of the list class in the .NET Framework, and as a result, is done will be true if current index is bigger than that or equal to that count. We use that down here. The only time I'm going to return a current item is if the current index, well, if it's not done, which means the current index is less than the count, which means that this is going to make sense. In my case, I chose to throw an exception otherwise, which I can catch wherever I called this from, or you could choose to do a number of other things. You could choose to ignore it and just let things go as they go. If you look at even iterator and odd iterator, I start even iterator at item 0 and increment by 2. The rest of it's the same. I set odd iterator to start at index 1 and increment by 2. The rest is the same. So in fact, we could simplify it a little. I think it maybe complicates it a little bit too by not putting certain ones of these. For example, is done looks the same in every one, which we could put up here in the abstract class if we wanted and just make is done defined there. I think it's better to do it this way because it's more readable. Sorry for all the scrolling here, but this is more readable to have all of these here together. you may be interested only in odd iterator at some point. And if you come here and then realize, man, I got to go back up there and look to see where it's at, maybe that's not what you had in mind really. Okay, so let's go look at the main form code. You've already seen it operate. You've already seen how load aggregate works. And this thing right here, populate list box, is the list box that is populated initially. It's this one right here. And what I want to do is show you how that's done. The first thing I do, and this is in the constructor for the form, so this is going to happen before the form's even displayed. First thing I want to do is create an iterator, and the iterator I want to create is the one that is associated with ag. In other words, something to iterate through this aggregate. I'm going to call its create iterator method, the aggregate's create iterator method, and I'm going to ask for a total iterator, meaning iterate through every item. And so what I do is I'm expecting to get this whole list of things. So let's look at populate list box. Pretty simple. It looks a lot like that code that I put on the board to show how iterators are similar to C style for loops. So here's what I've got. I've passed in the iterator object. I've passed in the list box object, and I'm clearing the items list on the list box. The list box has an items object which contains the list of objects that are in the list, and clearing it says take all of that stuff out of there. So then I'm going to say, well, for starting at this spot, checking to see if we're done, and if we get done with one, this is how we get to the next one. The same as exactly the same concept as is in a C for I equal 1, I less than 10, I plus plus kind of thing, except I'm just using first, is done, and next from the iterator that was passed in to decide what that sequence of things will be. And when I get one, if I fall into here, that means that I've got a live one here. I got something that I'm not done, and I've not done the dot next yet, so I'm still not done. I can use the iterator to get the current item and add it to the list of items in the list box. And that's exactly what's happening. So if I run this thing again, you can see that this is already loaded. And that's already loaded because I called that from here. The second thing is that we have this business of a couple of buttons that are there. This button and that button. And what we're going to do, I'm going to stop that. I want to come back over here, show you how we create those handlers. This is called an event handler. It handles the event that something clicked the button odd iterator. That's all it amounts to. This is where it was done. This is the object that caused this event to be raised. And this is some parameters that we're not going to use here about the event. And if we look at this, this is very much like what we did up here. This is in the constructor for the form. Here I'm just doing it based on when an event occurred. And if I clicked on the odd iterator button, I'm going to create an odd iterator and do it so that it iterates on only the odd items in the aggregate. I'm going to call populate list box, which is exactly this code, and return, and I'm done. So as you can see, we end up with an application that's really very simple. The code is very simple. The structure is almost identical to this. And by comparing your code to the structure in some detail, you'll find out perhaps that you missed something, like I did. I mean, again, I didn't do this on purpose. I didn't even do this for an instructional purpose. I just flat out messed that up. But now I know it, and I could go back there and fix it. Like I said, I left it there because I wanted you to see the value of comparing that to this, but I'm not trying to tell you that I made this mistake on purpose to do that. I flat out just messed up. So that's what we've got. And hopefully that will help you to understand the purpose of the iterators. Don't fall into the trap of exposing the underlying structure of your aggregate in your form, for example. You must go only through the iterator methods, first, next, is done, and current, to make this work properly. I know Bo in class today used the .NET Framework Iterator, IEnumerable, and create iterator, or get enumerator, I think it is, which is the get iterator essentially, from the .NET Framework. I would prefer that you not do that right now. We may in fact come back and look at that. I plan to come back and look at the .NET Framework iterators, but I think it's to your advantage to learn to do it, this one in particular, the old way, if you will, or the original way. So hopefully that was valuable to you. I will see you on Wednesday of next week, and I hope you have a safe and enjoyable Labor Day weekend. Bye.